Good afternoon, I'm Sarah Sargent, along with Kale Newfield and Gustavo Rodriguez. And we want to explain to you this problem. So we have a built-up section, an L section that is 8 by 7.5. So we break that into two parts. This is what we call 1, this is what we call 2. Our givens are that Fy equals 50 KSI, and we have a span of 12 feet. So this is our beam, and we have a load over 12 feet. To get started, we need to find our section properties. So for the area 1, we just find the area of it. It's 12 inches squared. Area 2 is also 12 inches squared. So the total area is going to be 24 inches squared. After that, we find our elastic neutral axis, or Y bar, by doing the sum of the AD dy over the area total. So that's 12 inches squared times 6 3/4 inch plus 12 inches squared times 3 inch over 24 inches. That gives us a Y bar of 4.875 inches. We also check for C, which is H minus Y bar. So 6 plus 1.5 inches minus our Y bar. That gives us 2.625 inches. Then we find our moment of inertia, and that is going to be the sum of the moments of inertia, which will equal 122.6 inches to the fourth.
Okay. So next we have to find our section modulus, and to find that we got to identify whether we're going to use I over Y hat or I over C, our extreme fiber. And what we're doing is we pick the greater one of the two. We've identified that as Y hat. So what we do here for section modulus, we plug in our moment of inertia that we found to be 122.6 inches to the fourth over Y hat, which is 4.875. We get, for the section modulus, 25.1 inches to the third. We then find the yielding moment, that is Fy times the section modulus. Fy is our given at 50 KSI. And we just found our section modulus at 25.1 inches to the third. We are in inches, so we need to divide it by 12 inches per foot to give us the yielding moment of 104.6 kip feet. We then find the plastic modulus, that is the sum of the areas, and in there for Z, 12 inches squared times 0.75 plus 12 inches squared times 3, which will then give us 45 inches to the cube.
And then to find our plastic modulus, we just took 50 KSI, which was given, times our Z to get 187.5 kip feet. And then we find our shape factor by dividing our plastic modulus by our My, which is Z divided by S. We get 45 divided by 25.1 to get 1.79. It has no units. And then we get our allowable load, which is Wn, which is W in L squared over 8, which equals 8 Mn over L squared, which is in 8 times 187.5 divided by 12 feet squared, and that equals 10.4 kip feet.